Hello and welcome to the discussion session for week 4. I'm Shreya, the TA for this one of the TAs for this course, and today I'll be discussing a few problems based on week 3 and week 4 lectures. So before going ahead, if you have any problems or doubts, you can ask me now. Is there anything from the previous? Yes. Alright, if there's nothing, then I'll just proceed with the sums. Is it okay? Can I start now?
Yes, ma'am.
Okay, thank you, ma'am. Alright, so the last week, that is week 3, the topics that we discussed were based on moments and inequalities. We learned about expectation, variance. We learned how to calculate moments, how to derive the higher order moments from moment generating functions. We learned about the probability generating functions. We learned about a few inequalities and we solved a few problems. So, going ahead, I would like to solve a couple of more problems. So, I'll just start off. So, this is the first one. So, we have been given a discrete type of random variable and the MGF has been given. Now, from here, it has been said that x is a discrete type of random variable. That means that x will take on some particular values and that will be associated with some particular probabilities. And we have been given the MGF of the distribution of x. Then from the MGF of a discrete type of random variable, how can we find out what the value of x is and what the probability of x is from this function? So how many values can x take on? That we'll get to know by looking at the coefficient of t in e to the power these terms. So here we can look at it as a into e to the power 0 into t plus b e to the power 2t plus c e to the power 4t. Alright, now whatever is the coefficient associated with t, that those are the values that x can take. Okay, so then x equal to 4 is one such value. The other value is this, x equal to 2. And here also we have x equal to 0. Okay, because we are taking this one. And the associated probabilities are coefficients of the e to the power terms whole together. So x equal to 0, probability will be a. X equal to 2, probability will be b. And x equal to 4, probability will be c. Is so far, is this clear how we can get the distribution and the
Yes.
corresponding probabilities?
Yes.
Alright,
Yes. Yes.
so this part is clear. So now we have the distribution. Now we don't know the values of a, b and c. So since these are probabilities, one equation is all probabilities should add up to 1. Okay, this we should keep in mind in case of a discrete probability distribution. In case of a continuous, what happens? The integral should be equal to 1 over the range of x. Okay, but since this is a discrete type of random variable, all the probabilities should add up to 1. So therefore we should have 1 a plus b plus c equals to 1. Let this be our equation 1. Okay, now further we have been given expectation of x and variance of x. So from here, let the distribution remain. So we already have this. So we have 3 unknowns. In order to solve for 3 unknowns, we need 3 equations. So one of the equations is expectation of x is 3. So now here so now expectation of x, how will we calculate expectation of x from here? This is summation of x into probability x equal to x over range of x. So this will be 0 into a, x into probability x, plus 2 into b, plus 4 into c. Okay, so this will be 2b plus 4c. Alright, now we have been given that 2b plus 4c equals to 3. Let this be my equation 2. Okay, is this part clear?
Yes.
Okay. Now we have 2 equations. We need a third equation and we have the variance value given. So easily we can calculate. Okay, now how will you calculate the variance?
Ex square minus ex whole square.
Okay, so then yeah, that's correct. So we'll just write down first how the variance of x equal to expectation of x square minus expectation of x whole square. Expectation of x is already given. So then we have expectation of x square minus expectation of x is 3, that is 9. Alright, this is equal to 2. So then this implies expectation of x square equals to 11. So now if we calculate expectation of x square from the table, then what do we have? We have 0 square into a plus 2 square into b plus 4 square into c equals to 11. That is 4b plus 16c equal to 11. Let this be my equation 3. Okay, so we have 3 equations in 3 unknowns. So now ultimately we have this. So if we solve for these 3 equations, what do we get? I'll write down the equations here again. Alright. So our equations were, the first equation was A plus B plus C equals to 1. The second equation was 2B plus 4C equal to 3. And the third equation was 4B plus 16C equals to 11. So what is A, what is B, and what is C? So multiplying this one into 2 and subtracting from here, we'll get 8C equal to 5, C equal to 5 by 8. Okay, we got the value C equal to 5 by 8. If C equal to 5 by 8, then from substituting here, B plus 2C equal to 3 by 2, then B plus 5 by 4 equal to 3 by 2, which implies B equal to 3 by 2 minus 5 by 4, that is 1 by 4. B equal to 1 by 4. And then adding these two and subtracting from 1, A will be how much? Can you please calculate? So these two will add up to something 7 by 8. So A will be 1 by 8. All of you got this?
Yes.
Alright. So then we have the distribution and the associated probabilities. A, B and C is known to us now. So then what will be 2 to the power x? Can you calculate? So we know what are the values of A, B and C. A is 1 by 8. B is how much? 1 by 4. And C is 5 by 8. So then expectation of 2 to the power x will be summation over x, 2 to the power x, probability x equal to x. So it will be 2 to the power 0 into 1 by 8 plus 2 to the 2 square into 1 by 4 plus 2 to the power 4 into 5 by 8. So this will be 1 by 8 plus 4 into 1 by 4 plus 2 into 5. So this will be 11 plus 1 by 8. 11.125 is the answer. Okay. Everybody got this? For those of you who joined late, are you able to understand? Oh, they left out. Alright.
Yes.
Okay. So I'll move on to the next one. So this one, we have been given that x is a random variable having a binomial distribution with parameters n and p. Then expectation of 1 by 1 plus x is given by which of the following? So do you remember the PMF of a binomial distribution? So probability x equal to x would be NCX p to the power x 1 minus p to the power n minus x, where x will range from 0, 1 to n. Okay, this is the PMF of a binomial. I'll write it as binomial NP. So this is how the PMF of a binomial distribution is represented. So now we have to find out expectation of 1 by 1 plus x. Same thing we will do. This is nothing but this is expectation of some g of x. Okay, so that will be summation of g of x probability x equal to x over range of x. Okay, so here we have expectation of 1 by 1 plus x. This will be summation x equal to 0 to n 1 by 1 plus x n c x p to the power x 1 minus p to the power n minus x. Is it okay? Now, any problem?
No.
Okay. Okay. So this we have. Now, I want you to carefully look at this part. Okay. So this one we can write it 1 by 1 plus x into ncx. I can write it as n factorial by x plus 1 into x factorial into n minus x factorial. So ncx I have broken down here and 1 by x plus 1 I have kept it here. Okay. Now combining these two, I can write it as n factorial by x plus 1 factorial into n minus x factorial. Now, if I want to write this as n plus 1, increasing both, so here I can write it as 1 by n plus 1 into n plus 1 into n factorial by x plus 1 factorial into n plus 1 minus x plus 1 factorial. Is this okay? So this thing I can write as 1 by n plus 1 into n plus 1 c x plus 1. Is it clear? So now
Yes.
instead of this one, we'll write this thing. So then so then this part I will write as equals to summation x equal to 0 to n 1 by n plus 1 into n plus 1 cx plus 1 p to the power x 1 minus p to the power n minus x. Okay. So now if I take it out, this thing, we can write it as 1 by n plus 1 summation x equal to 0 to n plus 1 c x plus 1 p to the power x plus 1. Let me write. So then I have to divide it by p into 1 minus p n plus 1 minus x plus 1. Trying to rewrite it in a binomial format. This thing, this p I can take it out and I can write it as 1 by n plus 1 into p summation x equal to 0 to n plus 1 c x plus 1 p to the power x plus 1, 1 minus p to the power n plus 1 minus x plus 1. Okay, now let me write y equal to x plus 1. So we have, from here we have y equal to x plus 1. So then this will be 1 by n plus 1 summation, let me write it in terms of x here again, n plus 1 c x plus 1 p to the power x plus 1, 1 minus p to the power n plus 1 minus x plus 1. This we had, no? So we are writing y as x plus 1. So into p here. So we'll have 1 by n plus 1 into p, summation y equal to x ranges from 0 to n. So y will range from 1 to n plus 1. n plus 1 cy, p to the power y, 1 minus p to the power n plus 1 minus y. Okay. So then this thing is a, if we would have had from y 0 to 1 n plus 1, this would have been binomial expansion of p plus 1 minus p to the power n minus 1. Okay, but since we are lacking here, this will be 1, that would have been 1. So p plus 1 minus p whole to the power n plus 1 would have been summation y equal to 0 to n plus 1, n plus 1 cy, p to the power y, 1 minus p to the power n plus 1 minus y. Okay, and this would have been 1. So since this is y equal to 0 term is missing, I can write it as 1 minus n plus 1 c0, p to the power 0, 1 minus p to the power n plus 1. So this will be 1 by n plus 1 to the power p into 1 minus n plus 1 c0 is 1, p to the power 0 is 1. We have 1 minus p to the power n plus 1. So this is our answer, that is this one. Is it okay?
Ma'am, can you explain last step again?
Okay. From where? Here.
Here p plus 1 minus p raised to
n
n plus 1.
Yes. So here if we have, let's say, p plus q to the power n, that will be summation zero to n, or k equal to 0 to n, n c k, p to the power k, q to the power n minus k. Alright. Now instead of q here, q we have 1 minus p. So here this thing, if I have 1 minus p to the power n, I can write it as summation k equal to 0 n ck p to the power k 1 minus p to the power n minus k. This one we can write. Now say instead of n we have n plus 1. So then this n plus 1 will come everywhere. Okay. Now this thing p plus 1 minus p plus q will always be equal to 1. So this entire thing will add up to 1, right, from k equal to 0 to n plus 1. But if you see carefully here, what we have is y is from 1 to n plus 1.
Okay.
If we include the 0th term in this equation, then we would have ended up at 1. But since we are
Yes, understood.
that's why we are just taking total 1 including 0 and then excluding the 0th term, y equal to 0 part, and that's how we land up over here. You got it, no? If it would have been y equal to 0 to n plus 1, it would have been p plus 1 minus p to the power n plus 1. P plus 1 minus p is 1.
Yes,
Since we are not
got
including 0, we are including 0 additionally to get this 1 and then subtracting the 0th part. Alright. So now I'll move on to the next question. Okay. So here the question is, it is known that a bus will arrive at random at bus stop sometimes between 8:30 a.m. and 8:45 a.m. So within an interval of 15 minutes, the bus will arrive at random. Now this person decides that he will go at random to this location between these two times and will wait at most 5 minutes for the bus. At most, maximum 5 minutes. More than 5 minutes, this person is not going to wait. And in case he misses it, he will take the cycle rickshaw. So the question is, what is the probability that he won't take the cycle rickshaw? In other words, what is the probability that this person Rahul catches the bus? This we have to find out. Now, let us assume R be the arrival time of Rahul and B be the arrival time of the bus. Okay. Now bus can come between 8:30 to 8:45. So I can assume that the bus follows a uniform random distribution. Since the interval is 15 minutes, I'll consider 0 to 15. Okay. So I will talk not in terms of absolute times but in terms of intervals. It can arrive 0 minute in an interval 0 to 15 minutes after 8:30 a.m. Okay. And this person can also arrive in this interval. Okay. Because he decides he will go between these two times. And they are independently arriving. Alright. So if I can represent it diagrammatically, then let's say this is the arrival time of the bus, and let this be the arrival time of the person. 0, 5, 10, 15, and here also 15, 10, 5. This is the arrival space of both the random variables. Now, probability that Rahul catches the bus is that he arrives before the bus. This is one. And the other condition was that he will wait at least 5 minutes, at most 5 minutes. So 5 minutes before the bus arrives, Rahul should be there at the bus stop before 5 minutes of the arrival of bus. So R should be less than equal to B minus 5. Only when Rahul arrives within before 5 minutes of arrival of the bus, only then he has to wait. He will get the bus within that 5 minutes interval. Is this part clear? How we can formulate in terms of the probability?
Ma'am, can just go to the previous page. First,
Yes.
Okay. We can just numbers.
So since this is time, R and B are time, so these are continuous variable.
Yes.
And uniformly distributed over 0 and 15. Because it can be any time point between 0 to 15 minutes. It's not discrete, it's continuous, and it can be at any given time point. So that's why we are assuming that both the distributions of the arrival times follow continuous uniform or rectangular distribution with A equal to 0 and B equal to 15, because maximum the time frame that we are looking at is 0 to 15 minutes between the 8:30 to 8:45 a.m.
Okay.
So we got this. So now probability he catches the bus will be he arrives before the bus and he arrives after 5 minutes. He arrives within that B minus 5 and B, because only then he'll be able to catch a bus. If he arrives less than B minus, so this is, let's say, arrival time of bus, this is B minus 5, this is B minus 10, this is B minus 15, and so on. So if he arrives somewhere over here, he will wait 5 minutes and then he is going to catch a rickshaw. So he will not get the bus. So only when he arrives here, then he will wait 5 minutes, he is going to catch a bus. Okay, so this thing translates to probability B minus 5 less than equal to R less than equal to B. Now, so here R equal to B, if we plot this entire area, this is our total outcome space. So when R less than equal to B, this line represents, this line represents R equal to B. Alright, and this line represents R equal to B minus 5. So when B 5, R is 0. Okay, now R has to be greater than equal to B minus 5. So R will be lying in this region, and R less than equal to B means this region. Okay, so now we have to find out this shaded area divided by total area. That will be our required probability. So area of the shaded region is how much? Is half into 15 into 15 area of this total triangle minus area of this smaller triangle. So this one here, when B is 15, R is 10. So this length is also 10, this length is also 10. Okay, so this will be half into 15 into 15, the total lower triangle, minus half into 10 into 10. This is the area of the shaded region, which will be half into 225 minus 100, that is 125 by 2. Okay, and the total area is 15 into 15, that is 225. Therefore, the required probability is half into 125 by 225. So dividing by 5, this is 25, by 5 this is 45, again by 5, 9. So 5 by 18. It is the answer. Probability: Rahul catches the bus equal to 5 by 18. Okay. Is this clear? Any doubt?
No, ma'am.
Alright. So if you were asked that probability he will take the cycle rickshaw, then what we had to do, we just had to do a 1 minus of this thing. Okay. Alright. Fine. So now I'll proceed to the next one. So the question says that a manufacturer doesn't know the mean and standard deviation of the diameters of ball bearings he is producing. However, a sieving system rejects all bearings larger than 2.4 centimeters and those under 1.8 centimeter in diameter. Out of the 1000 ball bearings, 8% are rejected as too small and 5.5% as too big. Then which of the following statements are correct? So how will you proceed? Can you tell me, what do you think is the starting point? Okay, so when yes, say
Um,
what is my random variable? What is the random variable?
this is discrete.
No, this is continuous, because first let us try to formulate our problem. Let x be the random variable. What is x doing? What is this manufacturing thing producing? It is producing ball bearings, and the measurement that we are taking is diameter. So let x denote the diameter of a ball bearing. Okay, now this one can take, if nothing is mentioned and x is continuous, because it can take 2.4, 1.8.
2.5. Yes, yes, got it.
Yeah, so it can take any distribution. So the safest thing to assume is that x follows some normal distribution with some mu and some sigma square. Okay, because we are not getting, like, from here we do not get the idea that it could be something else also. That's why we, typical use cases, we assume normality. Okay, but if it would have been something like wait time or some loss of memory is implicated, some sort of hint is there, then we have to choose our these things, the distributions, judiciously and thoughtfully. But since nothing is mentioned of that sort, it is little safe to assume that x follows a normal mu and sigma square. Alright, now they are saying, so if x follows a normal mu and sigma square, so we'll have a bell distribution, a bell curve like this, where this will be some mu. Okay, now they are saying if we are plotting x values in this region, so they are saying if the sieving system rejects bearings if x is larger than 2.4 centimeters. So let's say this is something here, 2.4 centimeter. So greater than this thing, it is going to reject, or those under 1.8 centimeter. So let this point be some 1.8 centimeter. So less than this also it is going to reject. Fine. Now what are the probabilities of rejection? So here they are saying out of 1000 ball bearings, 8% are rejected. So since we have been given the numbers in percentage, this absolute value doesn't make much sense. Okay, but had we not given this, I mean if this percentage values were not given, then we would have had to calculate 8 out of 1000. But they are saying 8% of 1000 means 80 out of 1000, which means 8 out of 100, 8% only. Okay, so probability 8% are rejected as too small. That means this area is 0.08, that is 8%. And similarly, this area is rejected, and what is the probability of or percentage of this area? This is 5.5%, that is the probability is 0.055. Okay, so then these probabilities are given. Now we have to find out what is the value of mu and what is the value of sigma. This is our task. Now, so for this thing, we can write our problem as probability. Let us consider the lower end at first. Okay, so this one, probability x less than or equal to 1.8 is given as 0.08. So usually during exams we will be given a Z table or the values of the Z table. What Z means? It's a distribution, it contains the probabilities of a standard normal distribution. Okay, normal 0, 1. This will usually be provided, either the values or the table itself. So we can do something. So here we can write it as x minus mu by sigma is less than equal to 1.8 minus mu by sigma equal to 0.08. Okay, so here if x, this is another thing that we should keep in mind. If x follows normal mu sigma square, then if we have some y equal to x minus mu by sigma, then that y will follow a normal 0, 1. Okay, so we will use this thing in order to derive our mu and sigma. So similarly here, instead of x, we are centering by mean and then dividing by the square root of the variance. So x minus mu by sigma less than equal to, on both sides we have to do, one side we cannot do, 1.8 minus mu by sigma equal to 0.08. So this we can write it probability some z less than equal to 1.8 minus mu by sigma equal to 0.08 where Z follows a normal 0, 1 distribution. Now from the Z table we have to find out at what value of this part, it corresponds to what value, such that the area under the Z curve is 0.008. So we look at how the standard normal table looks like. So you'll be given something like this. Okay, so these values that we have on the one second. So the values that we have on our left, and I highlighted with green, those are the Z scores. Okay, Z scores in, so if I, let's say if I want to know what this value represents. Okay, so this value represents probability that my standard normal Z is less than or equal to minus, so this is the first decimal thing and this is the second decimal thing. Okay, so it means it is less than minus 3.13 equal to 0.0009. You understood how to read this? So we have to find out probability Z less than equal to 1.8 minus mu by sigma equal to 0.08. So we have to find out this point. What we have to do is we have to look for the individual elements in this table which have just touched 0.08. Okay, so we'll go like this manner. All right, so we are going, the numbers are increasing, so you'll see it will increase in this fashion and in this fashion. So this it will increase like this, it is going to increase, then again this it is going to increase, in this fashion it is going to increase. Okay, so now if we go in this pattern, we'll see that from here somewhere we need 0.08, 0.05, 0.06, 7, 7, 7, 7, 8. Okay,
Your numbers are very small. Can it zoom?
Yeah, I'll zoom it.
Okay. Thank you.
Okay. 1 second. So here we are going in this manner, like this, then this, and so on. So near 0.08 we'll go and we'll check. So this is 0.061, 0.069, 0.07, 0.0474, 0.079, and here it touches 0.08. So the required value below which area is 0.08 is minus 1.4. That thing we got. So from this table we got that 1.8 minus mu by sigma is minus 1.4. Okay.
Ma'am, can you zoom it, please?
हाँ.
Actually, which one is closure? We don't have to take that.
We
Which
have
one
to
is
take.
ju-
See here they are saying the Z points represent those, and the table values represent the area under that point.
Yeah, that
Okay,
I understood.
that you understood.
Just good. Yeah,
Huh.
see, listen, ma'am, just right hand side of 0.808, that is 0.793.
Huh.
I think that is more closer to 0.8, no?
No, we have to choose a
0.8.
point which we can choose. See, this will be
Which
minus
one?
0.41, but it has not yet touched 0.08.
No, I am not telling that. Just right side, it is 0.793. 0.0793. I think that is more closer to 0.08, no?
I understand
This
where
is
your
8
concern is,
difference,
but
that is 7 difference. Means
yeah,
0, 0, 0.
yeah, it can be, but see, 0.7. So here, what if we take this, we'll have probability z less than equal to 0. Sorry, this will be, so here what we are saying, probability uh, z less than equal to something is 0.08. So this point we should be able to cross it.
You have to cross it.
Yes, it should be at least this, or we should be high, I mean a little higher, because if we say that probability z less than equal to 1 minus 1.41, then that will be 0.793. It will not be 0.08. But probability, this one, 0.0808, actually this is, we can take minus 1.41, then we'll get.
Yeah, which is closer, I think. Which is closer, no? We have to take that.
uh, Anyway, it will not make much difference, but yeah, you can take it if you
Okay,
think in
thank you.
that
Thank you.
manner. All right. So, but the usual convention is that we would take the one which touches or is very close to this thing. This is 0.7 and 0.8 also. Yeah, any of these if we can take. So it will be either just for some calculations purpose I have taken minus 1.4. You could also take minus 1.41. That is also completely fine. For the timing, I am proceeding with this thing. So then I have mu minus 1.4 sigma equal to 1.8. This is one equation that I have. Alright. So this one equation with mu and sigma we got. The next one is this end. We have to consider this end, 0.055. So here probability x greater than equal to 2.4 equal to 0.055. So we can write it as probability x less than equal to 2.4 equals to 1 minus 0.055 equals to 0.945. Okay. This we can write as probability x minus mu by sigma less than equal to 2.4 minus mu by sigma equal to 0.945, which implies probability sum z less than equal to 2.4 minus mu by sigma equal to 0.945. Now we have to find out the area where we have 945. So here we have 945, 945, 9452 is this area. Can you see?
Yes.
Okay. So this one, so this point, whatever we have is 1.6. So we can write it like 2.4 minus mu by sigma equal to 1.6, which implies mu plus 1.6 sigma equal to 2.4. Okay. So now we have two equations in two unknowns. What were the equations? The equation was mu minus 1.4, let's say 1 sigma only I will write. But in order to maintain this thing, I will just write to get answers to the correct thing, okay? But you can all definitely write this. So mu minus 1.4 sigma equals to, what was the value? 1.8.
8.
1.8, and this is mu plus 1.6 sigma equal to 2.4. This is 2, this is 1. So 2 minus 1, we have 0.2 sigma equals to 0.6. Sorry, this will be 3 sigma, because this is 2 minus 1, no? So this will become plus. So we'll have 3 sigma equal to 0.6. So sigma will be 0.6 by 2, 3, which is equal to 0.2. And then mu will be 1.8 plus 1.4 into 0.2 is 1.8 plus 0.28. So mu will be 2.08. Okay. You would get some more decimals if we have this thing. So mean 2.08 and sigma ST would be 0.2. All right.
Yes.
Okay. So once this is done, so what we discussed in week 4 was some discrete random variables, some continuous random variables, and some applications of a few random variables. So we'll do a few sums on these, and in the next class also we'll continue doing sums on this thing. So let us start with this one. So let x be a random variable that follows Poisson with parameter mu. Then variance in which of this is correct. So we have Poisson distribution with parameter mu. So what does this look like? Distribution of a Poisson variable. What is the PMF look like? So it will look like mu to the power x e to the power
Minus mu.
minus mu by x factorial or mu factorial?
X factorial.
And x will take values from
0.
0, 1, 2 and so on. It can go on and on and on. So this
And
is
third option is not visible. Third
Which-
option.
which
MXT is moment generating
okay,
function.
moment generating is not visible.
No. No. Third option in question. Okay. Yes. E raised to mu. E raised to p minus 1. Okay, ma'am. Thank you.
Okay, so this is there. So we got the PMF of a Poisson distribution. Now expectation of a Poisson distribution is
Mu.
variance of x is
Mu.
okay. So this one will also not hold true. Variance of x is mu, this is true. Expectation of x mu square is not true. Now expected value of and variance is not same for x, this is also not true, because Poisson is, they are equal. Now we have to find whether the moment generating function is this or not. So I will write it separately. Let x follows Poisson mu, then probability x equals to mu to the power x e to the power minus mu by x factorial. So now mgf of x equal to expectation of t to the power x. Okay, so this one we can write as summation x equal to 0 to infinity t to the power x mu to the power x e to the power minus mu by x factorial. Okay, so then this one we can write it as summation x equal to 0 to infinity t mu to the power x by x factorial to e to the power minus mu. So we can take e to the power minus mu out, x equal to 0 to infinity. We have t mu to the power x by x factorial. So now we can write this as e to the power t mu, because this of something known as power series expansion. Okay, so if we have something e to the power y, that can be written as summation n equal to 0 to infinity y to the power n by n factorial. So that will be 1 by 1 plus y by 1 factorial plus y square by 2 factorial plus so on and so forth. Now drawing parallels, here what do we have? Here we have, instead of y we have t mu, and instead of n we have x. So then this can be written as, so then this one mx of t, we had it summation, so we had it like e to the power minus mu summation of x equal to 0 to infinity t mu to the power x by x factorial, and this one can be written as so here instead of x we have n, instead of n we have x, and instead of y we have t mu. So this one we'll write as e to the power minus mu into e to the power t mu. Okay,
Yes.
so then this one we can write as, sorry, my this thing is only incorrect. It's e to the power tx, no, sorry, here only I
Yes.
made a
E raised to
mistake.
tx.
Yeah, I just wrote a incorrect format. Sorry, extremely sorry. This will be moment generating function. So moment generating function is expectation of e to the power tx. So then this will become e to the power tx mu x e to the power minus mu. So then this will become what? this will be mu e to the power t whole to the power x. Okay, so then we would have this one as mu e to the power t whole to the power x. So here also be mu e to the power t whole to the power x. So we would go to the power t whole to the power x. So here we would have e to the power mu e to the power t. This will be e to the power minus mu plus mu e to the power t. So if we take minus mu as common, or if we take mu as common rather, it will be e to the power t minus 1. You got it? E to the power mu into e to the power t minus 1. So if we have been given an MGF of a Poisson mu equal to e to the power mu into e to the power t minus 1. Got it? Moment generating function, this is MGF. This will be expectation of e to the power tx. Please don't do the mistake I did. It will be expectation of e to the power tx. Is it okay?
Yes.
So I'll proceed to the next one. So here we have number of customers arriving at a grocery store is a Poisson random variable. Okay, so on an average 10 customers arrive per hour. Let x be the number of customers arriving from 10 am to 1:30 am. So what is the probability that 10 less than equal to x less than equal to 15? So here we have in 1 hour how many customers arrive? 10 customers. Okay, so now our time frame is 10 am to 11:30 am, that is 1.5 hours. So therefore in 1.5 hours we would get approximately 15 customers on an average. Therefore let x be number of customers arriving from 10 am to 11:30 am. Then x follows a Poisson distribution with mean, lambda or mu as 15. Is it okay?
Yes.
So whenever we are given in some per hour time and some duration is given, what we have to do is we have to transform the average lambda value according to that time frame, and then we have to compute these things. Okay, so now we have this. So probability 10 less than x less than equal to 15. So what will it be? Probability 10 less than x less than equal to 15. Now in case of discrete random variables, we should be extremely cautious with the equal to and less than equal to sign. So it will be probability x equal to, it is greater than 10. So it is 11 plus probability x equal to 12 plus probability x equal to 13 plus probability x equal to 14 plus probability x equal to 15. So this will be e to the power, what will it be? We have to write the PDF. So the PDF was this, e to the power minus lambda. Lambda is what? 15. 15 to the power 11 by 11 factorial plus e to the power minus 15. 15 to the power 12 by 12 factorial plus e to the power minus 15. 15 to the power 13 by 13 factorial plus e to the power minus 15. 15 to the power 14 by 14 factorial plus e to the power minus 15. 15 to the power 15 by 15 factorial. And whatever we get, that will be the value. Is this okay?
Yes.
All right. Now we'll move on to the next one. So we have been given that x follows a Poisson distribution with mean alpha, y follows another Poisson distribution with mean beta, and these two are independent random variables. Alright. So now we have to find out the distribution of z. So x can take values from 0, 1, 2 and so on. Y can also take values from 0, 1, 2. Yes.
Hello, ma'am.
Yes.
In previous sum, mean is 10, no? It is given previous sum.
No, that's what I was saying. No. Mean is given 10, but that is what? On an average, 10 customers arrive per hour. The time frame we are looking at is not 1 hour. This is, instead of 1 hour, this
It is
is
1.5.
this is 1.5. This is 1.5 hours. So we have to accordingly calculate what is the average customers arriving in 1.5 hours. Alright, that's what I was saying. So if you have something like this, let's say number of errors per page is given to be 2 or 3, and you are reviewing a page of a book of, let's say, 200 pages, and you have to find out the total number of errors in that book is between something 50 to 100. Then you have to if per page it can have 2 errors, then the entire book on an average can have that number into, let's say, 30. That will be the average number of errors. So because we are taking that, because the random variable is defined in that manner, that x is the number of customers arriving in 1.5 hours. So then mean of x should be also in 1.5 hours, no? So that's how we have to translate to keep that duration same.
Yes, ma'am.
Okay, got it? Okay, thank you for this question. All right. So we'll go to the one that we were discussing. So let x be a Poisson alpha and y be a Poisson beta. Let these two be two independent random variables. Now we've defined a new random variable z as x plus y, and we want to find out what is the PMF of z. So first of all, we'll find out what value z can take. So if x can take anything between 0, 1, 2 to countably infinite, y can also take so, then x plus y, that is z, can also take values between 0, 1 and so on. Okay. So now probability z equal to z equals to probability x plus y equals to z. Is it okay? This entire
Yes.
yes. You want to say something?
No, ma'am.
Okay. So this one we can write it as probability z equal to x plus y equal to z. Now following the law of total probability, we can write it as I equal to 0 to z probability x plus y equal to z given x equal to I into probability x equal to I. Okay. This we can write, this is by total probability theorem. So x can take 0, then given x takes 0, y has to take z minus 1. Okay. So for each value of x, so this entire thing we can write it as some conditional probability into the probability of x equal to I summation over I equal to 0 to z. Now this one we can write it as summation I equal to 0 to z probability x plus y we can write it as probability y equal to z minus I given x equal to I into probability x equal to I. Okay. Now y given x, since x and y are independent random variables, then probability y given x equal to probability y. It doesn't depend on what x or y is. Okay. So then this thing we can write as summation I equal to 0 to z probability y equal to z minus I into probability x equal to I. And why can we do this? This is because x and y are independent. Okay. So now once we have this, we just have to now expand. So we have here probability z equal to z equals to summation I equal to 0 to z probability y equal to z minus I into probability x equal to I. Now y follows Poisson beta and x follows Poisson alpha. So this one we'll write as summation I equal to 0 to z y equal to z minus I. So it means we can write it as e to the power beta. So this is what lambda to the power x e to the power minus lambda. So e to the power minus beta beta to the power z minus I by z minus I factorial into e to the power minus alpha, alpha to the power I by I factorial. Okay. So then we can write it as e to the power minus alpha plus beta summation I equal to 0 to z b to the power z minus I alpha to the power I by z minus I factorial into I factorial.
I think.
Okay. So then this thing we can write it as e to the power minus alpha plus beta, okay, summation I equal to 0 to z. If we introduce z factorial over here and divide by z factorial over here, then what do we have? Z minus I factorial alpha to the power I beta to the power z minus I. So then what we are essentially having is probability z equal to z. I'll write from the previous one, okay. So we had e to the power minus alpha plus beta summation I equal to 0 to z beta to the power z minus I alpha to the power I by z minus I factorial into I factorial. So we are writing e to the power minus alpha plus beta by z factorial into summation I equal to 0 to z factorial by z minus I factorial into I factorial alpha to the power I beta to the power z minus I. So what we are writing is zci alpha to the power I beta to the power z minus I. So this is a binomial expansion of e to the power minus alpha plus beta by z factorial alpha plus beta whole to the power z. This one you understood?
Yes, understood.
Okay. So then what we have, e to the power minus alpha plus beta to the power z by z factorial. Then this is the PMF of what? This follows a Poisson with mean alpha plus beta. Just look at the parity, e to the power minus lambda to the power x by x factorial. Instead of lambda here we have alpha plus beta, and instead of here we are writing it as x, here we are writing it as z. It's the same thing because we are defining the z random variable. So if you have two Poisson random variables which are independent, then their sum will also be a Poisson random variable, and that mean will be summation of the individual means. Is it clear?
Yes.
Okay. So if this is done, then we'll proceed to the next one. This is very easy. What do you think it will be? So we have x follows a normal mu and sigma square. Then what is the distribution of y equal to 2x minus 6? Okay. So here if you find sums like this, you always remember that linear combination of normal random variables will always be normal. Okay, this can be proven. So little long, little more tedious in terms of calculation, but it can be proven. So if you have something like x follows normal mu sigma square and you have ax plus b or cx, then those will also follow normal distributions. Okay, any linear combination, a b could be anything. Okay, if you, yeah, so then y equal to 2x minus 6, y will also follow a normal distribution. Now for expectation and variance, we are going to use the properties that we discussed a couple of classes ago. So here we have x follows normal, what was given, mu and sigma square. Expectation of x is mu, variance of x is sigma square. Y is what? Y is 2x minus 6. So we know y, since it's a linear combination of a normal variable, is also normal. This we know. So now expectation of y will be how much? Will be 2 into expectation of x minus 6. For expectation, it depends on the scale as well as the shape parameter, or the mean and plus minus and into it both depends on that. Okay, so here we'll have, this will be 2 mu minus 6, but for variance y we'll have whatever x coefficient was there, that square into variance of x, so it will be 4 sigma square. Variance is indifferent in shift. So if we have x plus 6, because variance is essentially capturing the spread of a distribution, so it doesn't matter if the spread, let's say this one is centered around mu and we are shifting it to some mu plus 6 and the same distribution is shifted. What variance is measuring, it is measuring this spread thing. So the spread is not changing when we shift the mu or shift the distribution either on our right or on our left, but the variance or spread will change if we multiply x with something. It might, if this becomes too steeper, then the variance will change, or if it becomes too flat, then also this spread is going to change. Now that will happen when we have something multiplied or divided in the, we have some coefficient of x other than 1. Okay, so the bottom line is, whenever we are about to find out some variance of any random variable, that will be equal to square of the coefficient of the original random variable, and it will not take into account anything which is in plus or minus. So then our answer is that y follows a normal 2 mu minus 6 and this is the variance, 4 sigma square. Is it okay?
Yes.
Okay. So if that is done, so this is the last sum for today. So here we have been asked to assume the number of cars, the number of years a car will run is exponentially distributed with mean 8. Now suppose Mr. Alok buys a car today, excuse me, then what is the probability it will run after 3 years? So firstly let us write the, so exponential. Exponential is continuous or this thing discrete?
Discrete.
Continuous. Continuous.
Continuous. Exponential is continuous type of distribution. Okay, it's not discrete. So how does the PDF look like? An exponential is continuous and it can take on any value of x, or x has to be greater than 0. It has to be greater than 0. So the PDF of x is lambda e to the power minus lambda. So PDF we can write it as lambda e to the power minus x for all, sorry, e to the power minus lambda x, where x is greater than 0 and 0 otherwise. Okay, this is the PDF of an exponential distribution. Now we have to find that the probability it will run after 3 years. So we have to find out probability x is greater than 3. Okay, acha, what is the expectation of this variable, of an exponential variable of this format? It is 1 by lambda. You can easily derive this if we want. So expectation of x will be 0 to infinity x into lambda e to the power minus lambda x dx. Okay, so it will be lambda 0 to infinity x e to the power minus lambda x dx. So again, if we do by parts, we will have lambda x integration to the power minus lambda x minus d dx of x to the power minus lambda x dx. 0 to infinity. So x by minus lambda e to the power minus x minus lambda x, minus so it will be lambda or minus 1 by lambda square to the power minus lambda x. So putting infinity here, we'll have 0. Okay, or putting infinity here also we'll have 0. minus of, if we put 0 over here, this term will become 0, minus of, if we put 0 over here, it becomes 1 by lambda square. Okay. So here we'll have lambda by lambda square, that is 1 by lambda. So we know 1 by x, expectation of x is 1 by lambda. So here we have been told that it is distributed with a mean of 8. So what we have essentially here is expectation of x equal to 8, that is 1 by lambda equal to 8. So lambda is 1 by 8. So x follows an exponential distribution with mean equal to 8. Now we have to find probability x greater than 3. Okay. So probability will find out x less than equal to 3. That will be 0 to 3 lambda, that is 1 by 8, fx dx we can write it as. So 0 to 3 lambda e to the power minus lambda x dx. It will be 0 to 3 1 by 8 e to the power minus x by 8 dx. So then that will be 0 to 3 1 by 8 e to the power minus x by 8 dx. Okay, it will be 1 by 8 e to the power minus x by 8 by minus x by 8. Sorry, this will be e to the power minus x by 8 by minus 1 by 8, 0 to 3. So this will cancel. We will have minus e to the power minus x by 8, 0 to 3. So 1 is minus e to the power minus 3 by 8 minus of minus 1. So this is 1 minus e to the power minus 3 by 8. So what we got is probability x less than equal to 3 is 1 minus e to the power minus 3 by 8. Therefore, probability x greater than or equal to 3 will be 1 minus probability x less than equal to 3, and that value will be e to the power minus 3 by 8, and that is our answer, e to the power minus 3 by 8. Is it okay?
Yes, yes.
Okay,
Yes.
one thing I want to, yeah, anything you want to say? Okay, so one thing I would want you to note very carefully in case of exponential distributions, sometimes what will happen, you might be given this in a form that exponential, let y follow an exponential with lambda such that the fx is 1 by lambda e to the power minus x by lambda. Okay, x greater than 0. If you have been, if the parameter is given in this form, then the mean of x will be 1 by this coefficient, 1 by lambda, that is lambda. Okay, so just be a little careful how the PDF is being given to you. Okay, if you have something, let's say fx is 1 by 3 e to the power minus x by 3, then you can say that the mean is 3. But if you have something given as fx equal to 3 e to the power minus 3x, then you have to see mean equal to 1 by 3. So this is one small thing where sometimes there might be confusion. So just be careful about the parameterization of the PDF, how it is given.
Okay, thank you. Can we have a link for these solutions
What can
so
we
that
have?
later we can watch?
Yeah, the video recordings will be available. So I can see it. I don't know why you can't. I'll just show you how to do. I mean, I'll just stop my screen for some
Yeah,
time, and then please. And
because sometimes we may not be able to attend in those timings.
okay. So the recordings are available here. If you please let me know if you can see my screen
Not yet.
now.
Yeah,
Okay. So if you just log into your portal, here you will have the weeks and assignments.
yeah.
Here you will have something problem solving session July 2023.
1 second. I am logged in. I'll
Yeah,
check.
please
And
check.
actually, we have only if you okay. Yeah.
Is it there? So if
Yes.
you
Yes.
click on that link, you will find some yeah, this
Click
will
here
come.
to
Click
view
here to view
problem.
problem solving sessions, and here the
Okay.
YouTube links are given and the
Yeah. Yeah.
presentation folder links are also given.
Yes. Yes.
So
Thank
for
you.
all the TAs, so whatever you want, if you can't attend one of the sessions, all the sessions, you can just go and look at the recordings and
Yeah.
the problems also. But I would suggest you try to attend the classes, because there might be something during during the problem solving sessions that you might be confused in, and it's better to get it cleared then and there, instead of
Exactly.
waiting for the discussion forum and all sorts of things.
Yeah. Yeah.
So in case you miss it, you can always find it over here.
Yes.
Okay,
Yes.
we
Thank
keep
you.
on updating this. All
Okay.
right.
Thank
So
you.
thank you.
Okay, ma'am. Thank you.
Okay, thank you. So anything you want to say from today's session, or any problem where you need, like if I have to repeat from today's class, or
Uh, no, ma'am. As far as today's class is concerned, everything was clear.
okay.
Thank you for that. Nice
Okay.
session. Thank you.
Okay, thank you so much for attending.
Yeah.
I'll see you next week, where we'll try to solve
Only,
remaining
I mean,
problems.
one session, only 5 problems you covered, right?
I covered 10 problems, so the session starts from 3 o'clock.
Okay.
So try to join as soon as possible.
Only, I mean, per assignment, 10 problems will be solved.
Not like that. Like it
Okay.
depends on how much time it is going to take. Okay.
Only
So
one problem solving session per week.
so there are 3 TAs for this course. Okay.
Okay.
One class is on Friday, one is on that is today, and one is on Monday. So
Okay.
there'll be a lot of problems which will be solved by 3 of us. You can attend each of us and every one of us classes, and also look at the recordings to see what sort of problems are getting solved. This is
Yeah,
just an effort to help you with the assignment questions.
exactly. Thank you.
Okay. Thank you so much for joining. And if there's
Yeah.
nothing else, I'll close today's session, and
Yeah.
I'll see you next week.
Thank you.
Thank you. Bye bye.
Bye.